Okay, example 4 says find the coordinate vector of x equals that with respect to the order basis b. Okay, so what we've got to do is come up with the vectors that, or the coefficients, so that when we do c1 times 2, 1, 3, 2 plus c2 times 3, 3, 1, 2 plus c3 times 2, 2, 1, 1 plus c4 times 1, 1, 3, 4 gives us 12, 11, 19, 26. So that's the setup, and then we'll put this into a matrix. And row reduce it. And again, we know that this is going to give us I4 because those 4 vectors are linearly independent. So let's get Octave to row reduce this for us. Now I've already entered it into Octave as M4. Let's just double check it right quick. M4. Let's see, that should look exactly like what we've got there. So if I row reduce that, it gives me this. 1, 3, -2, 5. So that's my answer. What was this called? It was called X. With respect to B is 1, 3, -2, 5. All right. Now, this next example, 105, it looks a little different because it's written as polynomials instead of just vectors from R2 or R3 or whatever. But it works exactly the same way. What we're going to do is, and I'm going to write this one. I'm going to do a little scratch work, and then I'm going to write it straight into a matrix. So what we've got here for f, I'm going to call this. This is the same as like 10, -3, 5. And then my basis vectors down here are going to be, this will be 1, 5, 0, 1, -2, -3, then 4, -3, 4. It's not important the order you do these in, as long as you're consistent. So anyway, we get that. Let's write this as a matrix then. One thing, these vectors always become columns in the matrix. They don't become rows. So let's see, we get 1, 5, 0, 1, -2, -3, 4, -3, 4, augment with 10, -3, 5. And then we'll row reduce that. So let's see, is that correct? Yeah, just double checking that. So row reduce M5 gives us 1, 1, 2. So in this case, it's a function f with respect to this basis t. Its coefficient, its coordinate vector is 1, 1, 2. All right. Let's see. We've got one more example here. That's let's see. The coordinate vector of g with respect to the order basis t from the last example is 2, 0, 1. Find g. Okay, I'm going to just come back up here and copy this. Paste. All right, so what we've got here is 2, 0, 1. That's the coordinate vector. So what we're doing is we're going to multiply this one by 2, this one by 0, and this one by 1. So our g is just going to be, it's going to be 2x squared plus 10x plus 4x squared minus 3x plus 4. So we're just multiplying those 3 things by the coefficient above, and then we'll add them up. So G is going to be, let's see, 6x squared plus 7x plus 4. So for these kind of examples, there's really not a whole lot to them. The biggest mistake I see people make is either doing the opposite thing, row reducing when you should be just multiplying out, or vice versa. The other mistake I see people make on these is writing these in instead of as columns, writing them in as rows. So don't make those two mistakes, and you should be in good shape for all of this stuff.